This is a review for exam 4. It covers topics from chapter 6 and chapter 7, so focusing on quadratic functions, polynomial functions, and rational functions. Number 1, find all the zeros of the function below. So zeros is the same as x-intercepts, the same as solutions for these equations. We do need to simplify the answers as much as possible, and we are focusing on real zeros here. So the first one, x squared plus 2x minus 15 equals 0. This quadratic function is factorable, so we'll go ahead and factor it first. Two numbers that multiply to negative 15 and add to positive 2. That would be 5 and 3. And then on the signs, the plus has to go with the bigger number so that when you're adding it together, you get the plus 2. When you multiply the negative 3 and the 5 together, you'll get the negative 15. Now the zero factor property tells us that either x minus 3 is 0 or x plus 5 is 0, which means x equals 3 or x equals negative 5. We'll go to part B here. So 3x squared minus 75 does not have a middle term. It doesn't have a number with an x attached to it. So this indicates that it can be solved by the extraction of roots. So 3x squared equals 75. Just add 75 to both sides. Divide by 3. X squared equals 25. And then take the square root of both sides to get rid of the square on the x. When you're taking the square root of 25, don't forget the plus or minus in front of it. So x equals plus or minus 5. Part C is set up to be done by a U substitution technique. So we'll go ahead and utilize that here. So I first will let x minus 3, so the thing inside the parentheses, equal U. You can pick any letter, but U is most common. Then this same equation becomes u squared minus 5 times u plus 4. So we just substituted x minus 3 with a u equals 0. Now this is a factorable equation. So we'll go ahead and factor it. Two numbers that multiply to 4 and add to negative 5. Well, that has to be negative 1 and negative 4. So that means that u equals 1 or u equals 4. Now, that is u. That is not the answer for x. Then you have to go back to the substitution that you made and say, okay, then x minus 3 equals u, which is 1, or x minus 3 equals the second answer for u, which is 4. And then you solve the linear equations for x. So x equals 4. We add 3 to both sides, or x equals 7. Okay, part D, it's still a quadratic, cannot be done with the u substitution, really. So in this case, we just need to open the parentheses, do like terms, and then solve for x. So let's do that. 2x squared minus 5x plus 31 equals, I'm going to write it as x minus 5 times itself, x minus 5. So 2x squared minus 5x plus 31 equals x squared minus 5x minus another 5x plus 25. I'll go ahead and do the like terms on the right-hand side before dealing with everything else. Okay, now we have two quadratic functions on both sides of the equal signs. We have to move everything to the left-hand side and have a 0 on the right-hand side. So let's go ahead and do that. 2x squared from the left, and then minus x squared from the right. Then minus 5x, that was already on the left, plus 10x from the right, plus 31, that was already on the left, minus 25 moving the 25 from the right-hand side, equals 0. Then like terms on everything, 2x squared minus x squared, that's just x squared, minus 5x plus 10x, that's plus 5x, and plus 31 minus 25 is plus 6, equals 0. Now you can factor this much simpler equation. Two numbers that multiply to 6 and add to 5, 2 and 3, both are positive. And then we'll go ahead and do the zero factor property. So x equals negative 3, x equals negative 2. Number 2, you just need to find the function value at negative 3. So all you have to do is plug in negative 3 where you see the x's. Negative 3 squared plus a negative 3 minus 4 divided by negative 3 squared minus 2 times negative 3 minus 6 equals negative 3 squared is a positive 9. Then minus 3 minus 4, that's the top. Then the bottom, negative 3 squared, that's also positive 9. Then negative 2 times negative 6, that's a plus 12. And then minus 6. So we'll go ahead and add it all together. So on the top, 9 minus 3 minus 4, that is just 2. On the bottom, we have 12 minus 6, that's 6, and then 9 plus 6 is 15. All right, number 3, solve for x using the quadratic formula. So it's not factorable, give exact, fully simplified answers. So just to remind you what the quadratic formula looks like before we start on it. Okay, so that is the quadratic formula. In order to use the quadratic formula, your equation needs to be in a standard form. Our equation is not in standard form. Standard form has everything on the left-hand side and 0 on the right-hand side. So let's go ahead and move the 1. 2x squared minus 6x minus 1 equals 0. Then I'll go ahead and plug in the values in for the formula. B is negative 6, so that's minus a minus 6 plus a minus square root of negative 6 squared minus 4 times 2 times negative 1 divided by 2 times 2. All right, double negative on the front, that's a positive 6 plus a minus square root of 36 with the plus. Negative 6 squared is a positive 36. Then double negative inside, that's plus 8 divided by 4. So this is 6 plus a minus square root of 44 divided by 4. We have to fully simplify the answers to get all the credit. So that means we have to take a partial root out of the square root of 44. 44 happens to be 4 times 11 over 4. So that's 6 plus a minus square root of 4 is 2. Square root of 11 stays as a square root of 11. Now we still have to reduce this fraction. Now you could factor out a 2 and do it that way, but I prefer to split it into two fractions. 6 over 4 plus or minus 2 square roots of 11 over 4. 6 over 4 is reducible. So by 2, this is 3 halves plus or minus 2 over 4. Also reduce that square root of 11 over 2. Number 4, we're going to be using the graph of a parabola to answer some questions. Does the parabola open up or down? This one is opening down, so that ends up pointing down. What are the coordinates of the vertex? The vertex is either the max or the min of the parabola. So for us, it's a maximum, and it is at 2, negative 3. What is the equation of the axis of symmetry? So the axis of symmetry always runs through the x-coordinate of the vertex. This is your axis of symmetry. Equation means we write x equals and then the first coordinate of the vertex. What are the intercepts? X-intercepts. Well, our graph is not crossing the x-axis, so there's no x-intercepts on this one. Just none. And then the y-intercept, that's right here. That's where the graph crosses the y-axis, and it's at -7. We're going to put it in the ordered pair format, so x and y coordinate. Solving rational equations for y. The first one, 2 equals -4 over y minus 5. Y is in the denominator, so you got to bring it out of the denominator, which means you have to multiply both sides by the denominator. So 2 times y minus 5 equals -4 over y minus 5 times y minus 5. Now on the right-hand side, y minus 5 on the bottom and y minus 5 on the top will cancel out. So now you have 2y minus 5 equals -4. Open up the parentheses, 2y minus 10 equals -4. Add 10 to both sides, 2y equals 6, and then divide by 2. Y equals 6 divided by 2, or just 3. Part B, we have 4 plus 7 over y equals 5 over 3y. In this one, we have to use the least common denominator, and the least common denominator is both of the denominators multiplied together. So LCD is 3y. Then what we're going to do is we're going to multiply everything by the least common denominator. So 4 times 3y plus 7 over y times 3y equals 5 over 3 times 3y. Now, if you determined your least common denominator correctly, the next step should not have any fractions. So the y here and the y here will cancel. The 3 here and the 3 here will cancel. So if you can see on the next step, I will not have any fractions. So 3 times 4, that's 12y, plus 7 times 3, that's 21, equals just 5. And then we have to subtract 5y. Then we have to put all the y's on one side. That means subtract 5y from both sides. So that's 12y minus 5y. And I really don't want the 21 on the left-hand side. I want it on the right-hand side. So minus 21. Like terms on the left, 12 minus 5, that's 7y equals -21. And then y equals -21 divided by 7, which is -3. Okay, an applied problem. The ball is thrown from the initial height of 7 feet with the initial upward velocity of 44 feet per second. The ball's height in feet after t seconds is given by the following equation. Find all the values of t for which the ball's height is 27 feet. So h is 27. We need to figure out at what times the height is 27 feet. So we'll plug in 27 for h and then solve this quadratic equation. 27 equals 7 plus 44t minus 16t squared. First of all, we need to put this in standard form. So that means everything on the left-hand side, 0 on the right-hand side. So that's 16t squared minus 44t minus 7 plus 27. So 27 was already on the left-hand side, so the sign does not change. Like terms between -7 and 27. So 16t squared minus 44t plus 20 equals 0. Technically, we could reduce a little bit to help our numbers to be smaller, but I'm not going to bother to do this in this case. Just in case you didn't notice it, I want you to be okay with plugging in big numbers into a quadratic formula. So this is a quadratic formula equation again. So t equals minus b, so minus a minus 44, plus a minus square root of -44 squared minus 4 times 16 times 20 divided by 2 times 16. So that would be 44 plus or minus. Calculating the number underneath the radical, you should get 656. And then 2 times 16 is 32. Now at this point, I'm going to go ahead and break it up into two equations. So the first one will be T1, and that's 44 minus the square root of 656 divided by 32. And T2 would be 44 plus the square root of 656 divided by 32. Calculator. We're rounding to 2 decimals here. So the first one, that's 0.57 seconds. And the second time would be 2.18 seconds. Another graph that we're analyzing, this time it's not quadratic, it's a graph of a rational function. We are assuming that there's no holes in this graph and the asymptotes are shown as dashed lines. So state all the x and y intercepts. I'll try to color code it. So the x-intercepts is where the line crosses the x-axis. There's just one, and it is at 4. I'm going to write it as an ordered pair, 4 on the x, 0 on the y. The y-intercept is at -2. The y-intercept happens when the graph crosses the y-axis, and it is 0 for the x and -2 for the y. Vertical asymptotes. Well, this dashed line right here, that's a vertical line, so that is a vertical asymptote. It's going through the number x equals -4. So really that is the equation of that vertical asymptote, x equals -4. The horizontal asymptote goes through the number y equals 2. So y equals 2 is the equation of that horizontal asymptote. Now domain and range. Domain depends on your vertical asymptote. So this arrow right here is going all the way to the left, which means my domain or the x values start at -infinity. Then they go up to the vertical asymptote, which is -4. We do not include -4, so parenthesis. And then they start back up at -4 and go all the way. This arrow goes all the way to the right, so that is +infinity. Now, the range on this particular rational function depends on the horizontal asymptote. So once again, smallest to largest, but this time y values. So this arrow right here is pointing down and it's going to keep going down. So my range starts at -infinity. It's going to go up to 2. 2 is not included, so parenthesis, and then it starts back up at 2 and goes all the way. This arrow is going all the way up, so to +infinity. Number 6, you need to choose the correct graph for the end behavior of the functions that are shown. That is determined by the degree and the leading coefficient of the function. So this first function, please be careful and don't grab the first term necessarily. Sometimes the correct term is hiding somewhere in the middle or even at the end. So the degree is the highest power on the x, which is 4 in our case. So degree here is 4. Leading coefficient is -9. So even and negative, that is graph B. Then the second function, again, the term that you want is not the first one. So the second function, degree, is 5, and the leading coefficient is -7. So this time the function is odd and negative. That is graph D. The third function is in the factored format. So in order to figure out what the degree of that function is, you have to count all the x's. So there's one x here, plus in here, x is squared. So there's 2 of them there, plus there's one x here and one x here. So 1 plus 2 is 3, plus 1 is 4, plus another one is 5. So degree is 5 on this one. Leading coefficient is the number in front of the first x, since we didn't have any other numbers in front of the x's inside the parentheses, the leading coefficient is just 3. So this time it's odd and positive, which is graph C. Number 7, find a possible equation of the least degree of the polynomial with the given graph. So in order to do this one, you need to know what this is asking. And first and foremost, you need to determine the least degree of this polynomial. So let's go ahead and do that first. So the smallest degree of the polynomial depends on the number of turning points on the graph. So we have 1, 2, 3, 4, 5, 6 turns on this function. So turns, we have 6. The least degree will be 6 plus 1, or 7. So the smallest degree that you can have is 7, and that's what we're looking for here, is the smallest degree of the function. Now, after you've determined that, then you have to think about zeros of that function. Now, remember that zeros is the same thing as the x-intercept. So let's go ahead and count them, name them, if you will. So here's the first one. X-intercepts is where the function crosses the x-axis. Here's the first one at -6. X equals -6. Now, kind of look at it. The graph at that point touches the x-axis and bounces back off of it. It does not cross the x-axis. That means that the multiplicity is even on it. Then let's go to the next one. Here's the next 0. X equals -2. The graph is crossing through -2, which means that multiplicity is odd. This one, x equals 0, same thing, multiplicity is odd. Then we have this one. Yep, the graph is crossing at x equals 3, so multiplicity is still odd. I'm going to combine these. And then at 7, the multiplicity has to be even again because it touches and then bounces back off of the axis like a rubber ball thrown against the floor. So multiplicity here is even again. Well, we need the smallest degree, which makes sense for the multiplicity to be odd to just be 1, and for even multiplicities to just be 2. That will give us the smallest degree of the function. Now let's go ahead and do the general equation and then start filling it in. It's really not as difficult as it appears. It just takes a long time to explain. So we have the general format of this polynomial, or any polynomial in factored form. We have the a for the leading coefficient, which we don't know. So we're gonna assume it's 1, even though it probably isn't. Then x minus r1, x minus r2, and then it just kind of keeps going until you run out of zeros. So r's are roots or zeros or x-intercepts or solutions for this polynomial. So let's go ahead and plug in our numbers. So f of x equals a, we're going to assume it's 1 since we don't have any way to calculate it. Then x minus r1 was -6. Multiplicity was 2, which means we have to square it. Then we have x minus r2, or the second 0 was -2. That one's multiplicity once, just leave it alone. Then x minus 0, then x minus 3, and then x minus a -7. I'm going to go ahead and put plus squared. Okay, let me clean it up a little bit. F of x equals, we have x plus 6 squared, the double negative becomes a plus. Then we have x plus 2 to the first power. X minus 0, we don't put x minus 0 in the middle usually. We actually bring it out front, most likely. And then x minus 3, and then x plus 7, and that one is also multiplicity 2, so it has to be squared. So this is just the final answer. It doesn't look as bad as what it could. But we leave it in factored form, it just takes way too long to expand it. Number 8, we're just matching the graphs of the rational functions with the actual graph of that function. We're not using graphing calculators, we're truly just using algebra format, algebraic calculations for what we need. We need to justify our answers, so we need to calculate vertical asymptotes, horizontal asymptotes, and at least one test point. So let's go ahead and start with vertical asymptotes. So vertical asymptotes happen when the denominator is 0, so go ahead and set the denominator, just the denominator, equal to 0. Factor and solve for x. Two numbers that multiply to -3, that has to be 3 and 1, and they add to -2, so 3 has to be negative and 1 has to be positive. So the vertical asymptotes are at -1 and 3. Horizontal asymptotes. Those depend on the degree of the numerator and the degree of the denominator. For us, degree of the numerator is 2, degree of the denominator is also 2. So that means that the horizontal asymptote is at the line y equals leading coefficient of the top, which is 1, over the leading coefficient of the bottom, which is also 1. So just y equals 1 on this one. And then my test point, the easiest test point that you can pick is the y-intercept. So let's start there. And if we have to pick a second one, then we will do that. Test point, we have x equals 0. That's what y-intercept means. So y equals 0 squared plus 2 times 0 minus 3 divided by 0 squared minus 2 times 0 minus 3. So really it's just -3 over -3, which is 1. So we have the test point at 0, 1. So the graph should cross at that point. Let's look at the graphs. So we need the asymptote, the vertical asymptotes to be at -1 and 3. Look at A, that does not have the correct vertical asymptotes, so we'll skip that. Graph B has the correct vertical asymptotes, but the horizontal asymptote is at -2, not at 1, so it's not graph B. Graph C does not have the correct vertical asymptotes. Graph D has the correct vertical asymptotes. It has the horizontal asymptote at y equals 1, and the graph actually passes through the point 0, 1. So it is graph D for the first function. Let's look at the second function now. Vertical asymptotes, just the denominator, x squared plus x minus 12 equals 0. Factor. Two numbers that multiply to -12, add to 1, it has to be 3 and 4. 4 is positive, 3 is negative. Zero factor property tells us that x equals 3 or x equals -4. Horizontal asymptotes. Degree of this function on the top in the numerator is 1. Degree in the denominator is 2. So when the degree of the numerator is smaller than the degree of the denominator, the horizontal asymptote is the line y equals 0. That's the x-axis. And let's go ahead and figure out a test point. And I will start at x equals 0, so it's the easiest one. So y equals 2 times 0 plus 2 divided by 0 squared plus 0 minus 12. So that's 2 over negative 12, which is negative 1 over 6. So really, really close to 0, but it has to be slightly in the negative position. Let's go ahead and look at our graphs. 3 and negative 4 is our vertical asymptotes. Graph A actually has the correct vertical asymptotes and the correct horizontal asymptote. But the test point, it is negative, but it's way too close to 1. So chances are it is not graph A. Graph B, not correct vertical asymptotes. Let's look at graph C. Graph C has the correct vertical asymptotes, has the correct horizontal asymptote, and look at the y-intercept. It's slightly, very, very slightly below the x-axis. So it's in the negative direction, and it's very close to 0, which is what we have. So graph C looks very promising. My guess is that's what it is, but I have to check all of them. We already eliminated graph D, so graph E does not have the correct horizontal asymptote, and neither does graph F. So it is graph C. Right, next. On number 9, we need to state all the zeros and their multiplicities. I will also state whether it crosses the x-axis or bounces off the x-axis. Technically, we have to start with the step 3x, x plus 12 squared, x squared minus 36, x minus 2 cubed equals 0. Then we can use the zero factor property to separate it into terms. So 3x equals 0. We'll go ahead and divide by 3. X equals 0. Multiplicity on this one is 1. Multiplicity is odd, so it should cross the x-axis at x equals 0 at the origin. The next parenthesis, x plus 12 equals 0. That parenthesis was squared. X equals negative 12. Because the parenthesis was squared, it's technically two of them. X plus 12 times x plus 12. So multiplicity is 2. Even multiplicities do not cross the x-axis. They touch it and turn away. I like the term bounce because it's very visual. We've all bounced the rubber ball against the wall or against the floor, and that's what it looks like. It just bounces off. Then we have x squared minus 36 equals 0. X squared equals 36, which means we need to take the square root to get rid of the square. Don't forget the plus and minus. X equals negative 6 or x equals positive 6. So x was squared to begin with, but it didn't give us the same answer twice. It gave us two different answers. That means that both of those answers have a multiplicity of 1. And that means that in both of those locations, the graph will cross the x-axis. And then the last one, we have x minus 2 equals 0, so x equals 2. That parenthesis was cubed, so technically it's x minus 2 times x minus 2 times x minus 2 3 times. So x equals 2 has a multiplicity of 3. Odd multiplicity, it's going to cross at this 0. Number 10, we're analyzing a parabola. We need to figure out whether this parabola has a minimum or a maximum value. Okay, that's determined by the leading coefficient. So this negative 3 means that the parabola opens down. So it looks like this, which creates a maximum. So this is a maximum. What is the function's minimum or maximum value? Well, this is the y coordinate of the vertex. We can't figure out the y-coordinate until we have the x-coordinate of the vertex, which is part C. Where does the minimum or maximum value occur? And it has x equals in it. So this is the x-coordinate of the vertex. We gotta figure out that one first. So let's do that first. X-coordinate of the vertex has the formula minus b over 2a. So minus a minus 24 divided by 2 times negative 3. So that's 24 divided by negative 6, which is negative 4. So that goes right here. Then the y-coordinate of the vertex, that's the function value at negative 4. So that's negative 3 times negative 4 squared minus 24 times negative 4 minus 23. And if you calculate that out, it's 25, so that goes right here. Number 11, an airplane factory manufactures plane engines. The unit cost C, the cost in dollars to make each engine depends on the number of engines made. If X engines are made, then the unit cost is given by this function. What is the minimum unit cost? It does help to picture these a little bit. So if you just sketch a simple graph, this is X engines manufactured, and this is cost. There's a positive leading coefficient, so the parabola will look something like this. So it creates a minimum right here. This is the minimum cost. And this is the number of units that we need to make for the minimum cost. The question here is, what is the minimum unit cost? So we actually do have to figure out the y-coordinate of the vertex, but we can't do that until we find the x-coordinate of the vertex. So minus b over 2a to start with, minus and negative 280 divided by 2 times 0.4. And that is 350 engines. Don't box it in, it's an intermediate result. We just needed to figure out the minimum cost. So C at 350 engines, that would be 0.4 times 350 squared minus 280 times 350 plus 65,287. And then if you calculate it all out, that is $16,287. Number 12, we're analyzing graphs of the parabola. Part A, we just need to state whether the leading coefficient is positive or negative. Now, if the parabola opens up, the leading coefficient is positive. The first parabola opens up, so positive on the first one. If the parabola opens down, the leading coefficient is negative. So B and C have negative leading coefficients, and D is back to positive because it opens up on D. Which coefficient is closest to 0? So the smaller the coefficient, the wider the graph. So closest to 0 means the smallest, which means that this is going to be the widest graph, which is D. Which coefficient has the greatest value? Well, on this one, we do have to take into account whether it opens up or down. When it opens up, the leading coefficient is positive. When it opens down, the leading coefficient is negative. Positive numbers are bigger than negative numbers. So we immediately eliminate B and C because they open down, they're negative. So it's between A and D. Now, the bigger the number in front of x squared, the skinnier the graph. So this one would be the skinniest upright graph, which is A. Another graph of a polynomial, and we need to analyze it. So part A is state the interval an interval. We'll list all the intervals in which the function is increasing. I think it's more beneficial on that one. So all intervals on which the function is increasing. So that would be this one, and this one, and this one. We just take the x values, and it's always parentheses, never brackets. So that's from -8 to -5, then from -2 to 3, and then from 7 to 9. At which x value does the function have a minimum? And again, there's multiple ones, so I will list them all, and you just needed one for the question. So minimum is where the function switches direction from decrease to increase. So that's here, here, and here. We just need the x values. So x equals -8, or x equals -2, or x equals 7. What is the sign of the function's leading coefficient? That is determined by the end behavior of the function. We have left hand pointing up and right hand pointing down. So it looks like this. This is an indicator of a negative leading coefficient. Which of the following is a possibility of the degree of the function? And then we need to circle everything that applies. Now, in order to determine the degree, we need to first determine the least degree. So the smallest degree that this function can be. That depends on the number of turns that the function takes. So that's 1 turn, that's 2, that's 3, that's 4, that's 5, that's 6. So we have 6 turns, and then we have to add 1 to it. So the smallest degree is 7, but then it can be any other odd degree after 7. So 9 and 11 are also a possibility. Number 14 matches the polynomial functions with their graphs. Slightly different than rational functions, there's no vertical or horizontal asymptotes, but there is end behavior for these. So we will identify the end behavior and the zeros and then match the graph to the correct function. Let's start with the degree and leading coefficient. Degree for this function is 4. Leading coefficient is -2. So even degree, negative leading coefficient. Both ends will point down. Now we'll need to do the zeros of this function. We'll go ahead and set it equal to 0 first. -2 x to the 4th minus 2 x cubed plus 12x squared equals 0. Now, we can factor out the greatest common factor, which is -2x squared. So this will become positive x squared, positive x, -6 without any x's equals 0. We'll go ahead and keep going here to factor it completely. Two numbers that multiply to 6 and to -6 and add to 1. That's 3 and 2. 3 is positive, 2 is negative. Now the zero factor property, -2x squared equals 0. X plus 3 equals 0. X minus 2 equals 0. Okay, let's start with this one. If you divide by -2, it's going to be x squared equals 0. Take the square root, still going to be 0. Since it's just 0, multiplicity is 2. X was squared, so we got 0 twice. Plus or minus 0 is still 0. Since multiplicity is even, we're going to bounce in that x-intercept. So at 0, the graph is going to touch the x-axis and bounce off of it. It's not going to cross. X equals -3 on this one. Multiplicity is 1 odd multiplicity will cross the x-axis at this spot. X equals 2, and again, multiplicity is 1, so we'll cross at that spot. Let's go ahead and see if we can match a graph. So we're looking for the end behavior first and foremost. Not A, not B, not C, not D, not E, and we actually just have one graph that has both ends pointing down. Let's make sure the zeros fit. We have touch and turn or bounce at x equals 0. Yep, touch and turn does not cross. Then we have the graph crossing at -3. Yep. And the graph crossing at 2. Yes. So graph F definitely for the first function. Now the second function is already factored, which makes it a little bit easier to solve for zeros, but we'll start with the degree and the leading coefficient. Count all the x's. There's 1 here. And since this x is squared, there's 2 here, so degree is 3. And the leading coefficient is 1. There's no numbers in front of the parenthesis or in front of any of the x's. So we have odd degree and positive leading coefficient. The ends should look like this. Now zeros, x plus 1, x squared minus 16 equals 0. X plus 1 equals 0. X squared minus 16 equals 0. So x equals -1. Multiplicity on this one is 1. So the graph should cross the x-axis at x equals -1. X squared equals 16. Square root of x squared equals plus or minus square root of 16. So x equals -4 or x equals 4, two different numbers. Even though x was squared, two different results means that multiplicity is 1 on both of them. So it should cross at -4 and cross again at 4. Let's see if we can match it. The graph A does not have the correct end behavior. Neither does graph B. Graph C does. Let's see if the zeros match. We have a 0 at -1, that's crossing, and a 0 at 4, that's bouncing. That's not it. Let's try graph D does not match because of the end behavior. Graph E. So we have graph crossing at -4, that's a good sign. Crossing at -1, that's great. And crossing at 4, and the ends also match. So graph E is what you want for the g of x.